All right, and hello, and welcome to That's the Point. This is the place where we talk about construction, positioning, technology. My name is Corey Meyer, joined by my buddy Jeremy Horn. How's it going?
It's going good.
Back at it. So after all the T110 excitement, we're kind of getting back into it. And we're going to go back into the Wayback Machine. Back a while ago, we talked about the steady rest. We talked about the importance of making sure that your rod level bubble is always leveled and set. And the steady rest is a perfect way to do that. Make sure you click on that link down below. If you haven't watched that, it's a simple, easy tool to make sure every day that your rod bubble is set up. But what we wanted to do today is talk about the actual rod itself, because that's becoming more and more of a topic now that folks are knowing how to check their rod bubble. But now we're seeing that the rod itself can be torqued or bent. Maybe if it's a carbon fiber, sometimes those get crushed. But what we're seeing is those actually falling out of plumb and alignment, which is causing some accuracy issues. And we want to talk about some quick ways that we can actually check that today. So just to set the table, so we've got our RTS. It's already set up to the initial screen. We've got this setup rig here. This is just for demonstration purposes. Obviously, this isn't a typical layout setup. And what we want to do is, as we set this up, we want to make sure that we do all of these steps at your normal operating height, right? So if you've got an extension rod or extendable rod, you want to make sure you put that at your normal height to get started. But then the process is actually pretty simple.
Yeah, absolutely. I mean, all we're really doing is taking that distance that we can measure from the robot to our Prism and then rotating and checking that. So the way we're going to do that is when we first turn on our instrument and get connected, the first screen that pops up is our device setting screen.
Right.
So don't have to do a bunch of craziness. We're already on the screen. Get locked onto our Prism. And then we're going to look down at our HD live shot, which is our horizontal distance. All that's telling us is how far is this Prism from the robot.
Yep.
So if we get on a known point, set our rod up and make sure we're plumb. In this case, if you look at it, you see 10 feet.
Yep.
Right? We kind of set it up that way to make it simple. Then as we keep it on this point and rotate around, we should be maintaining that 10-foot distance. If we see any, deviations there, then we know there's something going on, with the rod.
Yep. So in this simple setup, that's what we can do. So we can actually just rotate the rod. So you're going to go through, we start at 45 just so you start to get an idea of where it's at.
Yeah,
right?
So we'll just keep on our point, rotate around here.
That looks like 45 degrees.
Make sure we're still plumb. It's missed it a little bit there. Make sure we got it there. And so now we're seeing 10 and an eighth. So we see about an eighth deviation there from us rotating here.
Yeah, that might have been me on the table too. This is not the most precise way of doing
Right.
this.
This is definitely, more for demonstration purposes for sure. So then we'll rotate back around almost to 180. And now we're actually seeing the exact 10 feet again. That 180 is key because if you do have some type of, bend in there, then when you go exact opposite, you are going to see a pretty big deviation from the original. Right?
Yeah, because what actually brought this up was real world feedback that we've gotten in the past couple of weeks. These residuals get large. Right?
Oh yeah. Well, coincidentally, not making this up, I got this specific call this morning before we shot this video. So, customer actually had a rod, wind knocked it over. Of course, while it was extended and they were working, started shooting and were getting some bad shots, over an inch. So his thought was that there was something wrong with the Prism. Looking at this thing, you figure it taking a fall might not be good. And so they wanted to send in the Prism to get it checked. And actually, did this practice here, and in doing this, we're determined that, hey, no, it's your rod. So most likely that rod was, aluminum piece was extended out. Rod took a fall, tweaked that piece,
yep.
and now when he was rotating it around like we're seeing, it was swirling around over an inch back and forth. So that rod, as it got up here, was just, doing this as we were moving it around.
Yeah, and it's a very timely reminder of the importance of checking this. And this is a great step where if it's one of those, if you see something, if you suspect it, so easy to check it, then you can have peace of mind knowing that your setup's good.
And truthfully, this is also checking your bubble. So if there was a case where you didn't have your steady rest with you or you didn't do that check, as soon as you connect to your robot and you do this is actually going to make sure both of those things are in line. Yep. Now, if you hadn't checked your steady rest and you do this, the next thing is figure out, okay, is it our rod or our bubble? Yep. But it is a way we can actually check both of those things.
Very cool. And of course, your building point representative is here to help with these specific type of issues. Make sure that your entire setup is solid and ready to go and able to be trusted. And of course, don't forget, smash that subscribe button to stay up to date with the latest tips, tricks, and pointers. Jeremy, thanks. We're back at it. Thanks for watching, and we'll see you next time on That's the Point.